and welcome to today's teaching. My name is Ola. I'm your tutor for today, and I'll be teaching the topic numerical processes, and we'll dive into series and sequence, arithmetic progression. So I would love you to go with me in this teaching and have a wonderful training. Thank you very much. So as I said earlier on, we'll be treating the subject of mathematics and the topic numerical processes. We'll touch the sequences and arithmetic progressions. But before I start, just imagine I gave you some money and I gave you 20 naira as your feeding money, and after an hour I had under 20 naira, and after an hour I had under 20 naira, making 60 naira, and after an hour I had 20 naira, making how much? Tell me. Okay, good, 80 naira. And after an hour I had 20 naira, making 100 naira. So you notice that each hour I had 20 naira to your feeding fee, making it increase by 20 naira every hour. So it has a rule or a sequence that increment is following. So as we proceed into the topics sequences, what is sequence? Sequence is a set of terms arranged according to a rules. Sequence is a set of terms arranged according to a rule. The rule can be used to obtain more terms of the sequence. What I'm trying to explain the other time in our starter is that each time I give you 20 naira, your money what increases. So each time I give you 20 naira, your money what again increases. So the rule to that starter is that in every 1 hour your money increases with what? 20 naira. Are you getting what I'm trying to say now? In every 1 hour your money increases with what? 20 naira. So it follows a certain rule every hour and 20 naira per hour. It is not 1 hour, then 2 hours, then 3 hours. Even if it's at that, it follows a pattern, a rule that it's moving from 1 hour to 2 hours to 3 hours. So there is a pattern it follows. That's what we call sequence. That is what we call what? Sequence. So for example, here they said find the next 2 terms in each of the following sets of numbers. Find the next 2 terms in each of the following set of numbers. The first one we have 1, 5, 9, 13, and 17. So we are to find the next 2 terms. That means the next 2 numbers that follows. Let's dive into the example as we solve it. Number 1, we have 1, 5, 9, 13, and 17. So we have to look for the next 2 terms. So to get that, we have to look at the rules of this set of numbers. We have to look at the rules of this set of numbers. We have 1 here. So what increments does this 1 have to give us 5? And what increments does this 5 have to give us 9? Could it be addition? Could it be division? Could it be multiplication? What kind of rule does this set of number follows? But looking at this, we have 1, we have 5, we have 9. We can easily say that we can add 4 to 1 to give us 5. Likewise, we can add 4 to 5 to give us 9. Likewise, we can add 4 to 9 to give us 13. Add 4 to 13 to give us 17. So we can see that the rule here is plus what? Plus 4 to each numbers. The rule here is what? Plus 4. So this is just giving you a critical thinking test for how can you decode the progression or the sequence of this set of number, the rules of this set of number. To give us what? 21. Then we had another 4 to this, so 21. So we have 21 plus 4, which will give us what? 25. Looking at this now, this is our result. We have 1, 5, 9, 13, 17, 21, and 25. And the rule of this set of number of this sequence is plus 4. the second example says we have 2, 6, 18, 54, 162, and we have to look for the next two terms. So what would be our rule for this? Looking at this, let us start with addition. What can we add to 6 to give us, what can we add to 2 to give us 6? We can add 4. But can we add 4 to 6 to give us 18? No. When we add 4 to 6, it's going to give us 10. That means the rule is not following the addition rule. Then let's look at subtraction. What can we subtract from 2 to give us 6? We can't subtract anything from 2 to give us 6, except we are going on the negative side of the numbers. Then let's look for multiplication. What can we multiply with 2 to give us 6? Okay, we can multiply 3. So 2 times 3 will give us 6. Then what can we multiply 3 with 6 to give us 18? Yes. 3 times 6 will give us 18. Likewise, 3 times 18 will give us what? 54. So the rule for this is multiplication. So we have times 3. So we can now say 162 times 3. What's 162 times 3 will give us 486. 486. And 486 times 3 will give us 1458. So that is the rule of this set of numbers. So to understand sequence, you must understand that a sequence follows a certain rule to give us the next term. And let's do the third example here, which we have 0, 5, 5, 10, 15. Then we have to find for the next two terms. So which rule does this set of number follows? Let's start with the addition. 0 plus 5 will give us 5. Okay. 5 plus 5 will give us 10, but this is 5 here. So it does not follow the addition rule. Let's go to the subtraction. What can we subtract from 0 to give us 5? There's nothing we can subtract from 0 to give us 5 unless we are going to the negative part of numbers. And if we go to multiplication, what do we multiply with 0 to give us 5? Nothing. Because anything multiplied by 0 will be what? 0. So what can we do? Okay, let's go for division. What can we divide by? What can we divide 0 by to give us 5? Nothing as of now. So this is when we have to think outside the box. So what can we do? We can say at this sequence, the progression of this sequence, we have 0, 5, 5. So I can think when we had the first two numbers together, we give us the third number. 0 plus 5, 5. 5 plus 5, 10. 10 plus 5, 15. Then what will now be our rule? Our rule is that we had the first two terms together and sequentially. So we do that sequentially. So we have 0 plus 5 will give us 5, 5 plus 5 will give us 10, 10 plus 5 will give us 15, then 15 plus 10 will give us what? 25. Then we say 25 plus 15 will give us what? 40. Can we see? Can we see the progression? So this is what we call sequences. So it follows a certain rule. The first rule is plus 4. The second rule here is multiply by 4. And the third rule here is we had the first two terms and do that sequentially to get our answers. So let's move to the next topic under sequences, which is arithmetic progression. So when we are talking about arithmetic progression, it's somehow like sequence, but arithmetic progression, which is also known as AP, is a sequence of terms that increases or decreases consecutively. That increases. Arithmetic progression, which is also known as AP, is a sequence of terms that increases and decreases consecutively by a constant amount, which is called the common difference. That constant amount is called what? The common difference. So this is the formula to calculate our arithmetic progression. Looking at this formula, it might look like magic, but let me explain the formula. The A in the formula stands for the first term. And what is the first term? Looking at this example, 9 is the first term in this example. 9 is the first term in this example. And D stands for the common difference. D stands for the common difference. While N is the nth term. Is the nth term. So let's dive into the example as we are trying to round off today's teaching, while we join us same time next week. Given the arithmetic progression of 9, 12, 15, and 18, find its 8th term, 99th term, and nth term. Now, when you are to solve anything in your mathematics, always try out to write out your parameters. Always try to write out your parameters. So, for what is our A? Remember, our formula is UN, which is A plus open bracket n minus 1 close the bracket D. So what is our A? According to this question, our A is the first term, which is 9. What is our D? The common difference. And how do you get your common difference in this? The common difference is the rule. You know, we've talked about sequences here. Is the rule of that sequence. Looking at this, we have 9, we have 12, we have 15. What do we add to 9 to give us 12? We have 3. We have 3 plus 12 will give us 15. 3 plus 15 will give us 18. So the common difference between each of these numbers is 3. Plus 3 will give us 12. Then we have plus 3, plus 3, plus 3, plus 3. We can easily get the number of this term, but to calculate your 99th term, then we have to do plus 3, plus 3, plus 3 up to the 99th places. But it's going to take a long period of time. That is why we resort to arithmetic progression formula, which makes it very, very easy for us to get the term of any progression. So since we know the common difference to be 3, then we move n. What is our n? N is the number of term. So we are looking for the 8th term. So we can say U8, which is the 8th term we are looking for, equals to 9 into bracket. What's our n? 8 minus 1. What's our D? 3. Then we proceed. We say 9 plus 8 minus 1 will give us what? Will give us 7. Multiplied by 3. So 7 times 3 will give us what? 21. So we can say 9 plus 21. So 9 plus 21 will give us what? 9 plus 21 will give us 30. So our answer is 30. So the 8th term is equals to what? 30. Hope we are following. The 8th term is equals to what? 30. That is for A. For B, we are still using this same perimeter, which is 9 and 3 for A and D respectively. So the nth term for this will now be 99. So we have U99th term equals to 9 plus, which is our A. Don't forget, open brackets. You have 99, which is our n, minus 1. Close the bracket. What is our common difference? 3. So we have 9 plus 99 minus 1 will give us what? 98 multiplied by 3. So 98 multiplied by 3. Let me continue like this. So we have 9 plus 98 multiplied by 3. So 9 plus 98 multiplied by 3 will be giving us 294 equals to, so 9 plus 294 will giving us 303. So the 99th term is equals to 303. Can you see, instead of us counting from here to the 99th term, which will take a long period of time, we've easily gotten the 99th term using our formula. And the third example, the C part is the nth term. We are looking for the nth term. So we say un, which is the nth term, we are not given any specific number, which is equals to, what is our A? Our A is 9 into bracket n minus 1, because n, we are not given the number of n, then d, which is what? 3. So we can, don't forget to add your plus sign here. Sometimes we easily forget the plus sign here. So we have 9 plus, how do we open this bracket? We multiply 3 with the number, with the number or alphabet in the bracket. So we have 3n, 3 times minus 1, we have minus 3. We've opened the bracket like that. So we have 9 plus 3n minus 3. So to proceed is to what? We can easily collect the like terms. We say collect the like terms. So to collect the like terms, we have 9 minus 3 plus 3n. What do we mean by collecting the like terms? They are looking at 9. 9 is an odd number without any alphabet attached to it. But n has a coefficient of 3. It has an alphabet attached to this 3 here. So we bring the one that looks alike, which does not have the alphabet beside them, and the one that has the alphabet to a side. Don't forget, your signs in front of each of your numbers are together, so you move them together as it has been taught in previous classes. So we have 9 minus 3 will give us 6 plus 3n. We can add 3n with 6. Adding been 6 is having an n, we can say 6n plus 3n, which is going to give us 9n. But since 6 is standing on its own without an n, and 3 is standing with an n, we can't add them together. Therefore, our final answer will be 6 plus 3n. That's our final answer for the nth term. So, with this, I think you've understand sequence and arithmetic progression. In next class, we move to geometric progression. But to recap whatever we've taught today is that sequence follows a what? Arranged number. It's an arranged term that follows a certain rule. It's either the addition rule, the multiplication rule, any other rules, but it must follow a rule. And when we talk about arithmetic progression, it's talking about that a sequence that can increase or decrease at a constant rate of amount consecutively. So, and don't forget our formula is un equals to a plus open bracket n minus 1 close the bracket d, and a stands for the first term, n stands for the nth term, and d stands for the what? The common difference. Thank you very much for joining us today. See you next week, same time, same channel.